So now, is
I think it's okay now. But yeah, speak with a louder voice. I think should be good. So go ahead.
So hello everyone, welcome to join this discussion. So I'm going to talk about the paper published in China, and this paper talks just mainly about the Earth's first sub-area craton crack, growing about 3.3 to 3.2 billion years ago. So the first author is the Chaudhary.
So Chunhao, could you speak louder? Your voice is still very weak.
Okay, I just changed voice. It is more clear now.
It's slightly better. So basically, you have to speak really loud now. Before, yeah, it's better, but you have to speak louder. Yeah, go ahead.
So Chaudhary got his bachelor's and master's degree at the Sarawak University of India, and he got his PhD degree at the Royal University in Germany. So I'll just do this discussion now. So this slide just outline this discussion. So firstly, the modern Earth is characterized by dichotomy of ocean and land masses, and formation of land masses that is land above sea level has a great impact on the surface system. And for example, the elemental cycling between ocean and land, long-term climate, and life evolution. So, in recent decades, scientists geologically around the world tried to explore the timing of emergence of area land masses in history. And for example, Tom and Barry are using the area proportion of reach and to constrain the match sub-area continents rising above sea level at about 2.5 billion of years ago. And other proxies that have been used to track the exposed history of land masses, also including the trip ocean, outcrop of shales, and also the digital Vulcan age distributions and the model calculations, as well as the potential and the length ratio of mafic volcanic rocks. These results are not consistent with each other. So here, the key question of this paper that also wants to know when and how of Earth's first crust or craton rose above sea level. So in this paper, they also just investigate the Singboom craton in India, and this craton possesses paleo to Mesozoic magmatic and sedimentary records, and is an ideal place to investigate this problem. So in this paper, firstly, it also just synthesized the detrital volcan data to determine the timing of emergence of Singboom craton. And this from this part just from the geological observations of the sedimentary rocks. And then also just try to reconstruct the history of crust thickening and chemical maturation before and during the emergence to explore the driving forces of the crustal emergence. And last but not least, they also try to use the isostatic modeling to explore the exposed history of this Singboom craton. So firstly, let's see, it is the detrital volcan age distribution. They also just compiled the age distribution of different parts of the craton. And we found that we have similar patterns of this age distribution. And also this age population is overlap with match bases of the granite magmatism of this craton. For example, the TDG and the potassium granite magmatism. And it means that this granite magmatism provided the source material to this depleter zircon. And then they also just use the zircon age combined with the timing of origins of this area, constrain the depositional age at about 3.08 to 2.93 billion of years ago. Therefore, combined with the terrestrial to shallow marine depositional environment and quick rich composition, and also propose that the Thinkful craton has already rose above sea level and experienced submarine sub-area weathering during this period. That is the geological observation. So we also try to explore the driving forces of this crustal immersion. So next, they also proposed that the granite rocks could record the magmatic evolution of the Thinkful craton before the crust emergence. So they also just plot the chemical composition of the TTG in this plot, and they also just found that there's a transition from older TDG, that is sodium-rich TDG, into younger, that is the potassium-rich granite during this period. And also, they also just plot. They also just found that there's an increasing in silicate oxide content increase from this period, and also decrease in iron and magnesium content during this period. The progressive chemical maturation of this Thinkful craton class. The most intriguingly, they also found that the higher RE depletion with the age of this TDG, so it reflects that the crust may be thickened with the age. So they also just try to find out the change of the thickness of this craton with time. So they also conducted the petrochemic modeling.
Okay, Chendao, speak louder. Speak louder.
Okay. So my voice is okay now. They also just conducted genetic modeling to explore which pressure could explain the HREE depletion. The modeling results showed that the pressure increased from 0.9 to 1.2 GPa from about 3.5 to 3.2 billion of years ago. And it corresponded to the increasing thickness of this craton from 32 to 45 kilometers during this period. And also just using another approach to constrain the thickness change, that is the Lanthanum to ytterbium ratio of the TDG, and we got the increasing thickness from about 32 to 40 kilometers, and this is consistent with previous one. So during 3.5 to 3.2 billion of years ago, the thickened crust 13 to 15 kilometers, and the cluster is the TDG formation depth increase and TDG become highly depleted. Okay. My voice now is clear now.
It's okay. Yeah, it's prefer you speak with louder voice.
You
So
hear me now?
yes, we can hear you. Speak louder. Go ahead.
Okay, last just conducted the isostatic modeling. It's a simple calculation, mass balance calculation. That is the low density craton and the high density and low thickness of the oceanic crust. So just calculate the craton thickness from relative low to at the about 3.5 billion of years ago to about 4 kilometers, about 3.1 billion of years ago. And also just assume that the ocean depth in a king area is about 4.4 to 4.7 kilometers, and the sixth boom craton emerged above sea level about 3.3 billion of years ago here, and about 3.1 billion of years ago, this area length varied about 340 to 1,100 meters here, and it is consistent with the geological observations of this craton during this period. They also compared with global ones. So the post history can be found on various cratons by about 3.0 billion of years ago on different cratons here, such as the Febra, Legrand, Silver, and Java, Capua. So in the end, the author proposed a mechanism that is mathematical thickening craton crack and crystal maturation caused the first craton crack above sea level in a non-plate tectonic environment. So this cartoon picture just summarizes the process of the sixth boom craton rising above sea level at during about 3.5 to 3.0 billion of years ago. So thanks.
Okay, Trindao, thank you for leading the discussion. For our participants, do you have any question for this paper? Actually, I first have a paper question start with. So they assume a certain depth of water in the Archean model, that is about 4 kilometers in terms of deep depth of the ocean. So of course, we don't know whether that is true or not. I think there are two things. The first is the total ocean mass in the Archean. I don't know. That's on the one hand. And on the other hand, also I'm curious about, for example, what's the because basically what the size of the ocean we have now basically is the volume of the, let's say, of course, it's the volume of the ocean of water, but also it's related to the basin. Let's say the geometry of the basin, ocean basin, that looks like. So that we are control the height or the depth of the ocean and therefore leading to how much of the rest of the land that's not covered by the ocean that become the land. So do you, Chen, so from this part, do you think that number, like I say, for example, the variation of that number in terms of the ocean depth, will have a result, will have a significant consequence, impact for the isostatic modeling they have?
Yes, definitely. Actually, we do not know. I think ocean depth. They also just, you can see this slide. They also just actually the city that one of the papers just that the sea level at about 3.2 to 3.0 was about 730 to 1,000 meters higher than present day. Actually, there's so many numbers about the ocean volume. So the depths are still do not know, and definitely it will influence the results. So if you see this figure, if the ocean depth is much higher, because, for example, 5 kilometers or 6 kilometers here, the ocean will not, the crust and crust will not emerge during this period, maybe later in 2.1. So it's a peak for this point, I think.
Okay, but okay. I mean, if you change the value, for example, the ocean depth from 4 kilometers to 3 kilometers or even 2 kilometers, how much does it have to?
If you change the ocean depth to small one or to low one, the timing of emergence of the sinkhole craton will be earlier than the 3.3 billion of years ago.
Okay, I see. So basically, you're doing something like the upper limit. But my interpretation is that, okay, your ocean depth also affect the isostatic modeling, because the thicker your ocean is, basically the heavier your, like I said, oceanic crust becomes, because that equivalent to your oceanic crust is a thicker, right?
Yeah.
It maybe not too much, because if you have that's a 3 kilometer ocean, then is equivalent to 1 kilometer of ocean crust thickness. So the density of the crust is about 3 times of density of the ocean water.
Yeah, if you change the volume of the depth of the ocean, I think it will not change too much about the modeling results, because I think that's the density or the density of the water will not influence too much about the oceanic crust, actually, because the ocean is composed of the rocks, and the water, I think, will have not too much influence about it.
Okay, so Ben, could you open your mic and ask a question?
Yes, I see the question on the chat. Yes, also when constrain the crystal thickness, they also just use the lanthanum ytterbium ratio of PDT. Actually, it has great uncertainty if you use this method, because of this ratio to the thickness getting come from the arc magmatism in modern Earth. So it's unreliable facts, but we do not have any other method to estimate the crystal thickness of arcane craft. So we already will actually we will know it is not accurate, but it's just a compression here.
Any more questions for Chuntao? Or comments about this paper? Yeah, the Lathrium is a iridium, is not iridium, is a
Ytterbium.
ytterbium, yeah, ytterbium ratio is still problematic. So actually for your office mate, the Luan Zhikan's work has already shown that this ratio doesn't work very well. Yeah, but so basically actually it all we're calling from machine learning to help with improvement.
Yeah.
So to him, have you worked on this Kraton before?
In this region, you mean?
Yeah, I mean, I bet you have worked on Indian Kraton.
Yeah, but my work was not exactly related to the TTG or this area, but yes, I have done a few analysis in one of the parts of the Singhbum Craton, which is known as Bonai granite, that was 3.3 billion years old. My work mostly involved something at the northern part of the Singhbum Craton, where the cyst belt is. So it's North Singhbum Mobile Belt and Gangpur cyst belt. So it's between like two continents, two cratons. One is Singhbum Craton, and at the north there is Chotnagpur Gneissic complex. So I have worked there in between the cyst belt for the metamorphism.
Actually, are there any kimberlite on this Kraton?
Sorry?
Are there any kimberlites?
No, not that I know of.
Okay.
Okay.
So now Wumi has a question.
Yes, the for this for example for the TDG here, also just to compile the TDG of potassium rich granite composition from the references, and for data filtering, I think they do not do data filtering. They just use the reported data. I think I did not find any evidence for the data filtering, not the paper use. Maybe we just, I think we just compiled about 10 or 15 papers. Maybe we did not collect all the available data, I think. Maybe we also just do not collect all the data, just compiled some of the data. Yes. the lantern to ytterbium ratio has a large spread, and also just use the median value here, this line, this median value of the data. Yes, for lanthanum and ytterbium elements, people usually will analyze these two elements. It's a parallel element in geological analysis. So previously in modern magmatism, some researchers claimed that this ratio correlates well with the crystal thickness, because the ytterbium is the higher ReE element, and this element will be affected by the by some spatial minerals that the garnet. So in hard garnet, if garnet exists in the south, in a second crust, the ytterbium ratio will be compatible in the garnet. So the lantern to ytterbium ratio will be higher in the melt. So we will observe the higher of this ratio in a second crust. But actually, the process may be complex and not so simple.
Yeah, Trina and Tuking, do you know the thickness of this lithosphere for this crater? Because I'm thinking that, okay, so you do the isostatic modeling. So basically you're assuming that in the end, people are trying to assuming that the assumption based on your mantle, right? Because you need to have the mantle density, have the crust density, then you have something that's about it. And if in different parts of it has a very different, for example, mantle density difference, and because in my recollection, the isostatic modeling that comes from the asthenosphere, so basically you're assuming something above it that is isostatic, although maybe it still be controversial, because even where is exactly the asthenosphere located is still something that is not that straightforward. So I think this part, especially when I asked a question earlier on to him, are there any kimberlite? If it doesn't have kimberlite, I think it also lacks some evidence for the petrological evidence for the lithosphere thickness. Probably that will only depend on the seismology to tell us. So Chunta, go ahead.
So are there any questions about this paper? Or something to discuss now? And for the isostatic modeling, they just assume a lot of parameters, and it is a lot of large activity of this modeling.
Okay. I think that's so much for paper reading for this paper today. Luan, I think you could stop recording. Okay, I think this paper